Hello everyone, welcome to the class of physics. Today we are going to solve the MCQs of chapter number 4. See the MCQ number 1. Equal currents are passing through two very long and straight parallel wires in the same direction. Then they will, when the current flowing through the two parallel wires, then what happen? If the currents are in same direction, then they will attract each other, and when the direction of current is in opposite direction, then they will repel each other. So, and what is the force acting two wires per unit length? Force per unit length is equal to mu naught I1 I2 divided by 2 pi d. D is the distance between two wires. So here they ask equal currents are passing through two very long and straight parallel wires in the same direction. They mean if the current is in same direction, then they will attract each other. This is our answer. Second question. A galvanometer of resistance 50 ohm is connected to a battery of 8 volt along with a resistance of 3950 in ohm in series. Galvanometer is connected which is having resistance 50 ohm. It is in series with 3950 resistance, ohm resistance, and it is connected to 8 volt battery. So the total resistance of this given circuit is 3950 plus 50 means 4000 ohm is the resistance. And so what will be the current through this circuit? Current is equal to V by R. So voltage is 8 volt and resistance is 4000 ohm. So current is 2 milliampere. A full scale deflection of 30 division is obtained in the galvanometer. So in 2 milliampere it shows full scale deflection. In order to reduce this deflection of 15 division, means you should reduce this deflection by half. So this current also becomes half. So the new current flowing through the galvanometer is half, means that is 1 milliampere. The resistance in series should be, so to do that you should connect a resistance of what value with this galvanometer. So you have to find R for this circuit. So galvanometer is same as initial galvanometer. So the resistance of galvanometer is 50 and battery is also same. So that is 8 volt. You should calculate this resistance R. The equivalent resistance now is R plus 50 and the current is equal to V by R equivalence. So voltage is 8 volt and current resistance is R plus 50 and your current is 1 milliampere, means 10 power minus 3, or you can write 1 milli is equal to 1 by 1000. So multiply R plus 50 is equal to 8000. So R is equal to 8000 minus 50. So series resistance you should connect with the galvanometer is 7950 ohm. This is our answer. 79, R is equal to 8000 minus 50. So that is equal to 7950 ohm. So D is our answer. Question number 3. Question number 3. As shown in figure, 20 ampere, 40 ampere and 60 ampere currents are passing through the very long straight wires PQR respectively in the direction shown by arrows. In this condition, the direction of the resultant force on the wire Q is. Current flowing through A wire is down, P wire is in downward direction. Current flow through Q wire is in upward direction, and current flows through R wire is in upward direction. Now on wire Q, the wire P and R applying force. See the current of P and Q both are in opposite direction. So P will repel this Q wire. So the force on Q wire by P is in right side, in the direction right side. So force by P wire is in the right side. Wire, see the wire Q and R. in both the wire currents are in same direction, so R will attract Q. So force by R wire is also right side. So the resultant force is because of P wire and because of Q R wire, both are in same direction, so your answer is also right side, means towards the wire R. What is your answer? Check the options. Towards right of wire Q. Yes, towards right of wire Q is our answer, B. Question number 4. Two very long straight wires are set parallel to each other. Each carries current I in the same direction and the separation between them is 2R. The intensity of magnetic field at a point P as shown in figure is. The magnetic field due to current carrying long wire is, there are two cases. If the radius of wire is A and current I is flowing through this wire, then what happened? This wire is of infinite length. Yeah, you can say that this wire is a long wire. So first case, whenever point is outside the wire, outside means the distance R is greater than radius of wire, distance R of a point is greater than radius of wire, then the magnetic field due to wire is mu naught I divided by 2 pi R. So that is inversely proportional to R. And for inside point, for R less than A, if the distance of point from the axis of wire is less than the radius of wire, then the magnetic field is mu 0 I A square divided by 2 pi, mu 0 I R divided by 2 pi A square. So magnetic field is directly proportional to R. And on the axis, if the point is on the axis of the wire, then R is equal to 0, so magnetic field due to wire is also 0, right? So the graph of variation of magnetic field due to very long current carrying wire is like this. It is directly proportional to R, and outside the wire it is inversely proportional to R. So maximum magnetic field is at the surface of the wire. This is the graph of variation of magnetic field with respect to distance of point from the axis of the wire. Now how to find the direction of magnetic field due to this wire? For that you should use your right hand. Keep your thumb in the direction of current. So your fingers will show the direction of magnetic field. Your fingers will show the direction of magnetic field. If you want to find the magnetic field at this point P and Q, then keep your thumb in the upward direction because current is flowing in upward direction. Your fingers are going inside, so at the point P the magnetic field is inside, and at the point Q your fingers are coming outside. So here at point Q the magnetic field is coming outside. So you can find the direction of magnetic field by using your right hand. Your thumb is in current direction and your finger shows the direction of magnetic field. Now in this question, two parallel wires are given. Both are carrying same current I. And the distance between them is 2R. And the distance of point P is R from this first wire. Now we have to find the intensity of magnetic field at P. Magnetic field at P is due to this first wire and due to this second wire. And we have to add both in vector form. So magnetic field due to this first wire is in inward direction. So that is equal to mu naught I divided by 2 pi. Distance of point from the wire is R. Magnetic field due to second wire is also in inward direction. And intensity of that is equal to mu 0 I divided by 2 pi. Distance between point and wire is r plus 2r, that is equal to 3r. So that is equal to mu naught I divided by 2 pi r into 1 by 3. So both field 1 and 2 both are in same direction, so resultant field is vector addition of both. Both are in same direction, so the magnitude of resultant field is addition of both. So that is equal to mu naught I divided by 2 pi r plus 1 by 3 into mu naught I divided by 2 pi r. So take mu naught I divided by 2 pi r common, that is equal to 1 plus 1 by 3, and that is equal to 3 plus 1, 4 by 3. So 4 by 3 into mu naught I divided by 2 pi r. So our answer is 4 mu naught I, 2 cancel, 2 mu naught I divided by 3 pi r. So 2 mu naught I divided by 3 pi r is our answer. C is our answer. Next question is, a proton is moving perpendicular to a uniform magnetic field. Let us discuss this topic, motion of charge in magnetic field. Motion of charge in magnetic field. First, whenever the charge is moving parallel to magnetic field or aparallel to magnetic field, means whenever the motion of charge is in same direction of magnetic field, charge is moving in same direction of magnetic field, or you can say that the charge moving in opposite direction of magnetic field. Here the angle between B and V is theta is equal to 0 degree, and here the angle between B and V is theta is equal to pi degree, pi radian. The force acting on charge due to magnetic field is Q into V cross B. So the magnitude of force due to a magnetic field on moving charge, that is equal to QEB sin theta. So in both case the theta is 0 and pi, for sin 0 and for sin pi, sin theta is 0. So sin 0 is also 0 and sin pi is also 0. So force acting on charge is 0. So charge will continue its motion with uniform speed. So with uniform speed it will travel further. Means whenever the charge enters in the magnetic field in the direction as same in the direction of magnetic field or in the opposite direction of magnetic field, then it will move with constant velocity. No force will act on that charge. Whenever it enters perpendicular to magnetic field, then what happen? Then the force acting on charge is QVB sin 90. Sin 90 is 1, so QVB force will act on it. Means whenever suppose magnetic field is in inside direction and the charge enters like this, then this charge will perform a circular motion. So you must know what is the radius of this circle and what is the time period of this circular motion. To find the radius, you should use this concept. The required centripetal force for this circular motion is provided by this force due to magnetic field. So mv square by r, that is equal to qvb. So the radius r is equal to 1v cancel mv by qb. This is the radius of this circular motion. And the time period of this circular motion is speed of charge, that is equal to distance covered in one revolution, that is equal to 2 pi r, and the time taken by the charge in one revolution is equal to t. So t is equal to 2 pi r by v. So 2 pi by v and r is mv by qb. So time period is equal to 2 pi m divided by qb. This is the formula for time period of motion of this charge. So you should remember these two formulas. And you must remember that whenever the charge enters in the magnetic field perpendicular to its direction, then charge will perform a circular motion. And the third case, in the third case, whenever the charge enters at an angle theta with the magnetic field, then what happens? Then the velocity of charge having two components. One component is parallel to magnetic field and second one is perpendicular to magnetic field. In this case, the parallel component is v cos theta and perpendicular component is v sin theta. Whenever the velocity is perpendicular to magnetic field, the charge will perform circular motion, and whenever the velocity is in parallel direction of magnetic field, then it will perform a linear motion. So this charge will perform linear and circular both motion combinedly, so it performs helical motion. Its path is helix path. So what is the radius of this helix and what is the patch distance of this helix? So you can calculate this radius of helix. The radius of helix is due to perpendicular component of velocity. So use same formula, but instead of v you should use the perpendicular component of v to calculate this radius of helix. And to calculate patch distance is a distance traveled by this charge in one circular motion. So speed is parallel to magnetic field and time taken by it is time period of circular motion. So v parallel into time period is 2 pi m by qb. So this is the formula for patch distance. So you should remember these two formula and remember these three cases. Whenever the charge enters parallel or aparallel to magnetic field, then this will perform a linear motion with constant velocity. Second case, whenever the charge enters in magnetic field perpendicular to the magnetic field, then that will perform the circular motion with radius r is equal to mv by qb and time period 2 pi m by qb. And whenever it enters in a magnetic field at an angle theta, then that will perform a helical motion with a radius of helix is this much and patch distance is this much. You should remember all these cases. These cases are much important for your examination for short question. And the force acting on charge is only whenever the charge is in motion. So on stationary charge, the electric field is applied force on charge. Only electric field is applied force on charge. Whenever the charge is in motion, then electric field and magnetic field both will apply the force on that charge. So total force due to both fields, that is equal to force due to electric field force plus force due to magnetic field. That force is called Lorentz force. That force is called what? Lorentz force. Total force on acting on charge due to magnetic field and electric field. Now focus on our question number 5. A proton is moving perpendicular to the uniform magnetic field of magnetic field intensity is 2.5 Tesla with 2 mega electron volt kinetic energy. Kinetic energy of proton is 2 mega electron volts. So what is the velocity of proton? Half mv square, that is equal to 2. Mega means 10 power 6 and electron volt, convert electron volt in joule by multiplying 1.6 into 10 power minus 19. So v square is equal to 2 to the 4 into 1.6 into 10 power minus 13 divided by m. Mass of proton is 1.6 into 10 power minus 27. So 1.6 cancel, that is equal to 4 into 10 power 27 minus 13 means 14. So v is equal to 2 into 10 power 7 meter per second. So this is the velocity of proton. The force on the proton in magnetic field is q into v cross b in vector form. The magnitude of force is q vb sin theta. The proton is moving perpendicular to magnetic field, so theta is equal to 90 degree. Charge of proton is 1.6 coulomb. 1.6 into 10 power minus 19 coulomb. Velocity of electron is 2 into 10 power 7 and magnetic field intensity is 2.5 and sin 90 is 1. So 2.5 into 2 5 into 1.6 8 into 10 power minus 19 plus 7 means minus 12 Newton. So this is the force, total force acting on a charge proton whenever it's moved perpendicular to uniform magnetic field. Question number 6. A particle of mass m and q is incident on xy plane with velocity v in the direction making an angle theta with a uniform magnetic field applied along the x direction. The nature of motion performed by the particle is whenever the charge enters with an angle theta with the uniform magnetic field, then this will perform a helical motion. So A is our answer. Seventh question. A very long straight wire of radius r carries a current I. The intensity of magnetic field B at a point lying at a perpendicular distance A from the axis is alpha. Then axis is proportional to what? Very long straight wire of radius r carrying current I. Intensity of magnetic field B at a point lying at a perpendicular distance A from the axis is proportional to what? When A is less than R. A is the distance of point and R is the radius. So distance is less than R. So magnetic field formula is mu naught I A square divided by 2 pi R. But here this mu naught I R divided by 2 pi A square in inside case when the point is inside the wire. But here the distance is given A and the radius is given R. Radius of the wire is given R. So B is proportional to A. So D is our answer. The magnetic field is proportional to distance whenever the point is inside the wire. There are 50 turns per centimeter in the length in a very long solenoid. It carries a current 2.5 ampere. The magnetic field at its center of on the axis is magnetic field due to very long solenoid is mu naught Ni. Mu naught is 4 pi into 10 power minus 7 and number of turns per unit length. So 50 turns per centimeter is given. So 50 turns per centimeter, you should convert this centimeter into meter. So that is equal to 10 power minus 2 turns per meter. And the current flowing through that wire is 2.5. So 2.5 into 4 is 10. 10 pi into 10 power 10 pi into 50 into 10 power minus 5. So 500 pi. So 5 pi into 10 power 2. So minus 3. So 5 pi into 10 power minus 3 Tesla is our answer. Ninth question. A straight wire of mass 200 gram and length 1.5 meter carries a current of 2 ampere. To suspend it in air by uniform horizontal magnetic field, the value of required magnetic field is whenever the current flowing through this wire is I and it is in magnetic field, then force act on this wire due to magnetic field is QVB. Force acting on current carrying wire is IL cross B. But whenever the current and magnetic field is perpendicular to each other, then theta is 90 degrees. So force due to magnetic field is ILB. Force acting on current carrying wire is given by IL cross B. And the another force acting on this wire is mg. To keep this wire in equilibrium condition, this ILB force must be similar to mg. So required magnetic field B is what? Mg by IL. So mass is 200 grams. So 0.2 into 10 power minus 1 kilogram. And G is equal to 9.8. Take G 10 for convenient. And current through the wire is 2 and the length of wire is 1.5. 2 gets cancelled. So this is equal to 100 by 15 into 10 power minus 1. So 10 by 15. So 2 by 3 is our answer. 2 by 3 means 0.66 is our answer. 0.65 is given in option number C. Tenth question, unit of Bohr Magneton. What is Bohr Magneton? Whenever electron is revolving in an orbit, then the current will flow because of this electron motion of this electron. So the speed of electron is v, then speed is equal to distance by time. So time period of revolution is 2 pi r by v. So current flowing through this electron is I is equal to q by t. So charge of electron is E and t is equal to 2 pi r by v. So this is the magnetic this is the current flowing through this motion of electron in orbit of radius r. Then what is the magnetic moment? Magnetic moment due to the motion of electron is NIA. Here the orbit is single, so number of turn is 1. Current is EV divided by 2 pi r, and the cross section area is pi r square. So pi gets cancelled, 1 r gets cancelled. The magnetic moment due to motion of electron is EV r divided by 2. You should remember this formula. You can relate this formula with the angular moment of electron. So angular moment of electron is mvr. So multiply and divide with m. So mvr. This mvr term is the magnetic angular momentum of the electron. So E divided by 2m into mu. Mu L is equal to E divided by 2m into L. In vector form you can write this as minus E divided by 2m into L, because the electron having negative charge. So mu L by L, magnitude of mu L by L is E divided by 2m. Charge of electron is constant and mass of electron is also constant. So this whole term is constant. This is called charge by mass ratio. Charge by mass ratio. And this constant term is also called Bohr Magneton. And this constant term is called Gyromagnetic ratio. This constant term is called what? Gyromagnetic ratio. And for electron, the gyromagnetic ratio is mu L by L is 8.8 into 10 power 10 coulomb per kg, because this is the ratio of E, charge by mass. Charge is coulomb and mass is in kg. And according to the Bohr postulate, the angular momentum of electron is multiple of h by 2 pi. So mu L is equal to E by 2m into nh by 2 pi. And for minimum angular magnetic momentum, consider this n is equal to 1. So EH divided by 4 pi m. Substitute all value, you will get the answer 9.27 into 10 power minus 24 ampere meter square. This value is called Bohr Magneton. So Bohr Magneton is what? The magnetic moment of electron, minimum magnetic moment of revolving electron. So that is called Bohr Magneton, and its value is 9.27 into 10 power minus 24 ampere meter square. So here only in question only unit is asked, so that is equal to ampere meter square. D is our answer. So for any magnetic momentum, the unit is number of turns, no unit, current ampere, area meter square. Ampere meter square is the unit. So Bohr Magneton is what? Minimum angular momentum of revolving electron. You can solve other question also related to this topic. That's why I am revising the whole topic during this solution. 11th question. A circular coil of wire consisting 100 turns, each of radius 2 meter, number of turns 100, radius 2 centimeter. So 2 into 10 power minus 2 meter. Carries a current of 0.20 ampere. The magnetic field at the center of the coil. Because of coil, the magnetic field on the axis at a distance x from the center of coil is given by B is equal to mu naught n I r square divided by 2 x square plus r square power 3 by 2, and at the center, take this x is equal to 0, distance of point from the center is 0, then b is equal to mu naught n I r square divided by r cube, so that is equal to 2r cube, so that is equal to mu naught n I divided by 2r. This is the formula due to magnetic field due to coil, current carrying coil at the center of the coil, and this is at a distance x from the center on the axis. So here they asked the magnetic field due to coil at the center of the coil. So use this formula, mu naught is equal to 4 pi into 10 power minus 7, number of turn is 100, so 10 power 2, current flowing through that is 2 into 10 power minus 1, 2, and radius is 2 into 10 power minus 2, so 2 gets cancelled, 2 2s are 4, so 2 pi into 10 power minus 7 plus 2 minus 5 minus 1 minus 6 plus 2 minus 4. This is the answer, 2 pi into 10 power minus 4 Tesla. You should remember the other concept also. At distance x is equal to plus or minus r by root 2, means in front of the point, in front of this coil and in the back side of the coil at the same distance r by root 2, the magnetic field is maximum. You should remember this concept, and to find the maximum magnetic field due to this current carrying coil, you should substitute the value of x is equal to r by root 2 in this equation. So note down all these important points whatever I am discussing here.